tonight?
So on the review, there's a lot of log problems,
Okay.
and I just realized how much I struggle with that. So,
Okay. Let's do some of them.
all right. Let's see. The first one is log 5, like the sub 5, and then 125.
Yeah, the way I pronounce that is log base 5 of 125.
Okay.
And I call 125 the argument. I'm not sure if that's what math teachers call it or not, but it seems as good a word as anything.
Okay.
All right. The way you're going to solve these, I think the best way is to introduce a variable. Let that equal to x. Okay?
Okay.
Now convert it to exponential. How do you convert this log expression to exponential expression? Every expression can go back and forth. For every log expression, there's an exponential equivalent, and for every exponential expression, there is a log equivalent.
Okay.
Okay? The most important thing to remember, logs are exponents. That means that has to be the exponent when you convert it to exponentials. Logs are exponents. So what would this end up being? Here's the way I do it. I take the number on the far left, I raise it to the power of the exponent, and it's equal to the argument. In other words, I start with 5 to the x equals 125. And now you can solve that without your calculator. What is x?
Oh, it's 3.
Yeah. Whenever they give you problems like that you're supposed to solve without your calculator, you know the answer is going to be a whole number. They're not going to give you one that has an irrational answer, a string of decimals.
Right.
All right. What else? Yeah, I tell you what, I want to give you a few just to make sure you're comfortable with going back and forth between log expressions and exponential expressions.
Okay.
So if 8 equals 2 to the third power, which it does, what is the logarithmic expression of that I just gave you?
It would be log base 3.
No, logs are what?
Exponents.
That means that thing has to be a 3.
Oh, right. Okay.
Now, what's the 2? The 2 is
Here's the base.
so that's got to go there. There's only one place left for the 8.
The argument.
And now if I convert it back the other way, I got 2 to the third power equals 8.
Okay.
Okay? So get very comfortable. You can't even begin to learn logs unless you learn that. How to convert log expressions to exponential and back and forth.
Okay.
What else do you got?
Log base 5 of 1/5 equals -1.
Okay, what do they want you to do with this? That is a true statement.
They want us to rewrite it in exponential form.
Okay, go ahead and do it. Tell me what it is.
So it'd be 5 raised to the -1 equals 1/5.
Is that a true statement?
Yes.
Yeah, because 5 raised to the -1, or is that?
Okay.
Okay. What else?
I don't really remember natural log.
Okay, natural log is just a different base. Instead of base 5, it's base e. So instead of always writing it like this, it is the most common log. When you get to calculus, it's the only log you'll ever use is natural log, pretty much. So they've shortened it to that. But that's what it means, is log base e. What is e? E is a number that's approximately equal to that.
Okay.
It's the second most important number in all of math, right after pi.
Okay.
Okay. So,
We
that's
solve
a
it
log of what?
6.9.
Is it an equation or an expression or?
It says with using a calculator.
Okay. That's a big part of it. That means that we cannot do this without a calculator. There is no manual way to do it. Before calculators, you had tables. You had to look up logs of numbers. Most logs of numbers are not whole numbers. They're irrational. Okay? So look that up. What kind of calculator do you have, Jake?
TI-84.
There's a natural log key on there. There's a log key, which is base 10, and there's a natural log key. Hit the natural log key and then follow it with 6.9.
Okay. I got 1.9 about.
Okay. And what that means is that e to the 1.9 power would be equal to 6.9. Now that makes sense. 2.7 squared is in that ballpark. So yeah. I don't know how much they want you to round it off. Do they give you instructions? How many decimal places?
3 decimal places.
All right, then 1.9 isn't good enough. You're going to need 4 figures.
Yeah, 1.932.
And that's not enough. What's the fourth one? I mean, maybe you're already rounding it off. Are you?
Yeah.
Okay. For me to check whether you're rounding it off correctly, I need the fourth one after the 2.
Okay, so it's 1.9315.
Okay. You're correct. That does round off to 2. Okay. What else?
Let's see. Oh, log of the square root of 2.
Okay. Radical signs don't work very well beyond a certain point in math, so we always convert them to fractional exponents. That's how you write the log of square root of 2.
Okay.
Now, are you supposed to do this in your calculator?
Yeah.
Okay. You can do it 2 different ways. You can use your log key, and then you can put 2 to the 1/2 in the argument, like that, or 2 to the 0.5, or you can even probably do the log of square root of 2.
Okay.
There's some log properties that we need to talk about. Absolutely. Okay? Let's just go over them. There's 3 log rules that are extremely important. I know you have to know these. When you are multiplying inside the argument, you can separate that into 2 log statements. The log of A plus the log of B. Multiplication translates to addition, just like exponents. That's what logs are, is exponents, so it should be exactly the same. The log of A divided by B in the argument is going to be what?
Log A minus log B.
And the third one that is not so obvious, but nonetheless is true, is the log of a raised to the b power, you're able to bring that b down and put it in front of the log on the algebra line. So it becomes that. Okay? Now, you definitely have to know all three of these by heart, but you also have to be able to go both ways. They're going to ask you to expand, which goes that way, and then they're going to ask you to compress, which goes that way.
Okay.
Okay? But these three rules, you have them memorized? Can I erase it?
One sec. I'm gonna take a picture because we get to use a note card on the final.
Okay, that's definitely one of the big things you want on there, especially if you have any confusion about logs.
All right, I got it.
Okay, now let's find some problems that ask you to condense or expand, since we were talking about that.
Okay, here we go. Log base 5 of 8 minus log base 5 of 12.
And this is what? Is it an expand or a condense problem?
It's condensed.
Because there's two log expressions, we want to turn it into one log expression. Is it part of an equation or is that it?
That's it.
Okay. So what's single, and incidentally, these three log rules only work if the base is the same.
Okay.
If that's log base 4, can't do anything.
Right.
So all of these rules require the base to be the same. So what is that?
So it'd be 8 over 12?
Yeah. And they expect you to simplify that. So that's actually the log base 5 of 2/3.
Okay.
Okay? What else? We should do a few condense, and then we should definitely do a few expand.
Okay.
Because that's going to be a big part of your test. You're going to have to do multiples of both.
All right. Another condensed one is natural log of 16 minus natural log of 4.
What's that going to be equal to?
Natural log of 16 over 4, which would be natural log of 4.
There you go. That's the answer.
Okay, that's not bad.
No, it's real simple. Once you get, they can make them a lot more complicated, though. I'm hoping we get a little harder degree of difficulty here.
Okay. Log base 3 of 2 plus 1/2 log base 3 of y.
Okay. Now, when you're condensing, I have found the best first step is to get rid of those leading coefficients.
Okay.
In other words, this 1/2. Let's get rid of it first.
Okay.
So what am I going to do with that 1/2?
You raise it to the y?
Y gets raised to it.
Okay.
And then I erase it from there. In other words, that is the same as having the 1/2 down in front. Okay. Now we've got the addition of 2 log. Let's turn that into 1 log expression.
Okay, so it'd be log base 3 of 2 times y raised to the 1/2.
Just like that. Now, in this case, you cannot take that 1/2 down in front because the 2 is not being raised to the 1/2. Only the y is.
Okay.
That's why you do the first part first. In other words, why you get rid of the leading coefficients first.
Okay.
All right. That's usually the last step you do when you're expanding, is to do the leading coefficients last, or to do the exponents last, bring them down as leading coefficients. So you are basically doing it in the exact reverse steps.
Okay.
What else?
10 log x plus 2 log of 10.
Okay. Well, first.
So we have to move the numbers in front of log.
So that becomes what?
It'd be log x to the 10 plus log log 10 to the 2.
Okay. Now combine that into 1.
Would be x to the 10 plus 10 squared.
No, everything in the argument is going to be multiplied, not added. The log statements are added, but what that translates to when you compress it is it gets compressed in the argument. It gets multiplied in the argument. Well, first of all, what's 10 squared?
100.
So it's 100 times x to the 10th power.
Okay.
There's your answer.
Okay.
Okay. Just get the pattern down, and it's the same exact pattern on all the problems. Doesn't matter how many variables there are. If I give you something like this, expand that.
It would be log x squared.
Go ahead. Plus, you can do it in steps, yeah.
Okay, plus log y cubed plus log z to the 10 minus log a minus log b.
Okay, and then the last step of expanding is to bring those coefficients back down in front.
Okay, so it'd be
this is probably the most valuable of the rules that is used the most frequently in advanced math, is being able to bring that exponent down to the algebra line. And there's your expansion. You got started with 1 log expression. We ended up with 5 because there's 1, 2, 3, 4, 5 variables in the argument.
okay.
Okay.
Should we move on to expanding?
We can, yes. I'll let you direct since we only got like 10 minutes left here. You direct.
Natural log of 22x.
Expand that. That's it, right?
Yeah.
Okay. What's going on in the argument right now?
Multiplication.
Okay. So it's going to expand into 2 what? 2 logs that are being added.
Right. So would it be natural log 22 plus natural log x?
That's it.
Okay, that's not bad.
No, pretty easy once you get the hang of
Okay.
it.
Log base 6 of 10 over 3.
Equals what?
Let's see. So that's going to subtraction.
Okay.
It'd be log base 6 minus
Hold on. What's the argument of that?
log 10
Log base 6 of 10.
of 10. Okay. Minus log base 6 of 3.
Okay. That's it.
Okay, cool.
Uh-huh.
Log base 2 of 9x.
Go.
Log base 2 of 9 plus log base 2 of x.
Yeah. Multiplication goes to addition, division goes to subtraction, and exponentiation goes to multiplication.
Okay.
Okay? Now, there can be some tricky ones. About that one.
Would I use the division equation for the log?
No, there's no division. There's multiplication going on. The question is, how do you deal with that radical? Let's deal with the radical sign first.
Um,
How can I write square root of 18?
um, 18 negative 1/2.
Not the negative, just the positive 1/2. Positive 1/2 exponent means square root. 1/3 exponent means cube root. Okay. Times x. And now write it. Keep expanding it.
Okay, so log of 18 to the 1/2 plus log of 18.
Just the only thing it's being multiplied by.
Yeah, log of x.
Now there's one last step for expanding it.
1/2 log 18 plus log of x.
There you go. So whenever you run into a radical sign, change it immediately to a fractional exponent, and then just deal with it as an exponent.
Okay. Natural log of 3x y cubed. So that's multiplication. Natural log of 3 plus natural log of x plus natural log of y cubed.
Which is 3 natural log of y. Okay?
All right.
Couple of other things that I bet you're going to end up having to know. One is, what's that equal? What's that equal to?
That's 7. That's 0. All right, because 7 to the 0 is 1.
You got it. What's the natural log of 1?
That also 0?
All logs of 1 are 0. So if you take the log of 1, it does not matter what the base is. Any number to the 0 power is equal to 1, and that's why this is true. Okay. Another nifty trick that they may give you is this. That's equal, what's that equal to? Figure it out. B to what power is equal to B?
The first power?
Yeah, always is 1. In other words,
Okay.
if I say, what's the log base 17 of 17? That's equal to 1. So as long as these two numbers are the same, it's always equal to 1.
Okay.
Which means when you see something like this, now you didn't give me any problems like this, but not to say they won't have them. First thing I'm going to do is bring down the x. So that x can now go in front. Even if it's a variable, you can still do that. And what's that?
That's 1.
Okay. So that is always equal to x. Or if that's an x plus 2, then it's equal to x plus 2. So if you have the log base of the same number to some exponent, you can immediately it's equal to that exponent.
Okay.
Okay? Got 3 minutes. You got one last one you want to do?
Yeah. Log square root of x cubed. And there's like a little 4 in between the, yeah, right there.
What that means is the 4th root of x cubed.
Okay.
Now, how do you write that as a fractional exponent? Is there more, or is that it?
Oh, that's it.
Okay. How would I write that as a fractional exponent? That's the key.
Um,
The root is the denominator of the exponent, and the power is the numerator.
okay.
So x to the 3/4 means the 4th root of x cubed. X to the 2/3 would be the cube root of x squared.
Okay.
And once I've written it like that, now I can expand it by just bringing that 3/4 down in front. There's your answer.
All right, sweet.
Okay, one last thing. What's this?
That be 0?
Well, so if it's base 10, 10 to the 0 equals what?
Is that 1?
So it's undefined. It's impossible to do. It actually gives you imaginary solutions, much like when you take the square root of a negative number. In other words, the only things you can take logs of are positive numbers. You can't even take the log of 0. You can take the square root of 0, but you can't take the log of 0.
Okay.
All right, Jake, good luck. If you need more help, I'll be around tomorrow night.
All right, perfect. Thank you.
You're welcome. Bye-bye.
Bye.